Hello.
Hi. Just sharing the YouTube link to the communities as well. Um, there. Okay. So, hi. Say we. Okay, that's irritating to see myself. Okay. Um, say we just wait a few more, see if other people join us.
So this is going to be about software architecture and stuff like that.
Yeah, exactly. We'll be talking about basically how we can write code that is better maintainable over multiple months or even years.
hmm
And there we got a few, um, basically a few topics that can help that many indie devs maybe never heard of, because many indie devs are also, hobby developers. So of course they do not have a professional computer science training or programming training, or how you would call that in German, in English. Um,
uh, your mic just cut off or something.
okay, that's interesting. Sorry.
Oh,
For some
yeah, okay.
reason, it just muted me. Yeah, so we basically want to just share our knowledge as software engineers with indie devs who maybe do not have that background.
Yeah,
That's
that's
why we,
interesting.
yeah, that's why we also want to have a small part where we um, go into depth a little bit about Unity and how to handle that stuff there. Um, I got people posting on the old YouTube link that is not working.
It's quite interesting, and because I ran into this problem like this week. I was making a game engine, and when I tried to put everything into folders and then change some stuff around, and everything just broke, and I had to go back to previous version to try to fix it.
uh, yeah, it's basically every project meets that point someday, whether you pay attention to it or not. I mean, it's not like we don't have those problems ourselves. That would be a very big lie. So does that work? Okay. So I guess we've waited long enough. Um, ha Probably half the people missed it now due to those complications. But yeah, we don't need that many people for a presentation and a small discussion, don't we? So then I'd like to welcome you to the next Art of Games Hangout. This time basically hosted by Brutal Hack. That is myself, Benjamin Justice, Sergei Tikhonov here,
Hello?
and Eike Wolf. And wait, I just see we lost him. And I don't know why he ain't coming back. which is a little problem because he's supposed to present. Do you want to call him? Yeah, okay. Sergey's gonna call Eike so we can actually present. Yeah, I'll just talk a little about how this will work. So basically, we will start off with a presentation by us three about software architecture for indie game devs, and then we will go basically open it up to a discussion so that we can trade out expertise and past experience with each other. This presentation is not just for Unity, but also for other game engines. We personally hardly use Unity. We use Java. So we are going to go a little into depth about Unity, but not too much. And the things we say are applicable to, yeah, basically any game engine. Yeah.
I got a quick question for you.
Yeah.
So, why Java, given the JVM kind of interpreted machine differences? When you're in game dev, performance is always a big concern. What led you guys to think that Java was going to be the best thing for you?
For one, Java is not does not have that performance issue that people believe it has. Wait a second here. I gotta give him that link again. Okay. Because Java optimizes a lot nowadays. Back then, in the good old days when it was Java 1.4 or something, it was definitely much slower than it is now. Nowadays, it's very much optimized, and yes, you can easily be faster than a Java application, but that basically requires that you are proficient in C++ or another very, yeah, a very low-level language compared to Java. And to be honest, we had a look at it, and modern computers are just so amazingly performant that it doesn't matter if we have a JVM overhead or not. I mean, if we were to program the next Crisis, then maybe, but we're not, so that's not an issue.
Yeah, I was just curious. It's one of those things that you hear brought up a lot. I assume at most of our levels, we're not so down to the metal that that we're going to be writing a game that fast anyways, I assume.
Yeah. Okay, so now that we are complete, I'd say it's about time that we start a presentation. This is going to be a little awkward for me because it's the first presentation in my life where people can't see me, because I did try integrating Google Drive, but that's, I assume, a deprecated feature, sadly. So now, does everyone see the presentation?
Yep.
Yes,
Okay.
I see it.
Okay, yeah. All right, so then let's start. Our topic is, as I said 500 times before, software architecture for indie game devs. Who are we? Benjamin Justice, Sergey Tikhonov, and Eike Wolf from Brutal Hack, a very, very young indie studio that hasn't released anything yet. We are computer science students. We are currently in our last master semester so that we can have our master's degree. Experience are over 2 years experience with Java development, partly because of university projects in Java, but also in our private project, which is the game written in Java, which I will say something about soon. And yeah, can you deal with that, please? Yeah, and over 6 months experience with developing in Unity on a commercial project. Okay, our current project is Aileron. It's a tactical MMORPG written in Java with JMonkey Engine 3, That's an engine that basically abstracts OpenGL and nasty things like that for us so that we can focus on the meat of the game. And as you can see here, it's a big project, one that will be in development for a long time, so it's very important that we pay attention to how it looks code-wise. Yeah, overview. We will begin with a quick motivation as to why software architecture is important in long-term development and why it can help us. Then Eike will be giving a small talk about clean code, which is basically code quality on a almost line of code based level. And then we will be talking about two architecture patterns, model view presenter and entity systems. And lastly, we'll be speaking about components in Unity and how they can be structured properly. Okay, at this point, I want to tell you all that there is a small slide number here in the bottom right, because we thought it would be better if you would ask questions after the presentation. That means it would be best if you were to write down the slide number and your question, and then ask it later. It's just an experience we made over the years of presenting stuff. All right. Why do we need this all? The thing about games, why it's even more critical than in normal software development, is games tend to just grow in time. You have new features that you want to implement because maybe you find out, oh, that's not that difficult to implement it. Let's just throw it in. It's awesome. It changes the game completely. Then you have new conditions. Maybe a new platform is released, like the Ouya, and you think, ah, cool, we can support that. And then you have new controllers that you have to support, and it needs its own code. Then you have user feedback. If you're like on Kickstarter, Greenlight, or just classical beta, you will get feedback from your users, and they will say a lot of things are bad, and you'll have to, fix it that it pleases them more. And lastly, you got bug fixes. Now, all these things tend to increase the complexity of your development enormously. If you just look at your game that you wanted to develop when you started, and after you developed, it will probably be much bigger. So, how can we survive such a long-lasting, evolving project? Now, one thing that can definitely help is having a solid code base. And with that, I will now pass the torch on to Eike, who will be talking about clean code.
Okay. Hello, everyone. Can everybody hear me well?
Yep.
Okay, so just as said, we want a solid code base, and one of the fundamentals for this is having good readable code. And this is because you write the code once, and then you come along again, and you need to fix a bug, and you need to understand again what did you do here. And then imagine you're two people or three, like we are, and then I come along, the code Justice has written, and I have to understand what he did, and suddenly it's not you reading your code, because you say, okay, I will obviously know what I did. Well, see about it in half a year. You come along at the code again and you say, what did I do here? And then after maybe 5 minutes, if you're lucky, maybe half an hour if you did really bad stuff, you know again what you did. But in half a year later, you forgot again. So you might want to change that so you can read it easily. And if you are with several people and just comes along my code and says, wow, this is really ugly, and then he reads it and understands it, and then he thinks, okay, I know how to do this better, and then he will change it. you will say, okay, I will change this, for example, variable name, and he does not have to ask for permission or something. He will do this because this is our code and not my code. And we do all this to maximize the readability of the code we have. Yeah. So clean code, well, it's not like we came up with this. You might have heard that there's a book. And so we just took a few things out of the book that are easy to take up and effective. And so we just give them to you so you can think about them and then try to use them. It's not like you will use them at once and then you're done with it, but you have to learn to use something like this. So, and we'll just start with coding conventions. It doesn't matter if the coding conventions you use are good or bad, but if you use coding conventions, your code will be consistent, even if it's consistently bad. You will know to expect the same things everywhere, and therefore you know how things are going to look, and certain things are going to be certain things. So if your coding conventions say you have an like m underscore for members, then you know this m underscore is a member. It will never be a local variable. So the problem with coding conventions is, so I do a slight tangent here, is you need to enforce them more or less. And if you do all this by hand, it gets very tedious. So you should, in my opinion, always use a good IDE for whatever language you are using and configure this IDE to enforce the coding conventions like you want them. And then suddenly the code is in the format you want it without you having to work for it. And this is always the best thing. Like not having to work for increased readability. So there's a link. You'll get the slides in the end, I guess, to C# coding conventions. These are from Microsoft. And for Java, there's some by Oracle, there's some by Google. Probably you'll just Google them and then read some. And if you don't like something, you can change it. It's not like you have to use the industry standard, but they probably had good reasons because why this is the industry standard now. Okay, moving on to naming things. So this is when you program, you start with a blank slate and then suddenly you create a thing, and this thing is completely not from this world. So you create things out of thin air, and then you're not really sure what this thing is going to be, and then you give it some name. It's called bar in the beginning or stuff. And then if you come along later, you don't know what stuff is supposed to be. So when you come along stuff, find out what stuff is supposed to be and give it the name that it really is. And this is not easy, of course, because you want to tell people everything they need to know. So you need to be precise. You should not be able to mix them up with other names. Then you need then it needs to be short because space is precious in programming. And if it's not a variable but it's a method, it tell you something. It should tell you everything you need to know to use it. And why is this the second thing, and this is in the book. It's a whole chapter, because if you have a good name, then you do not need, in most cases, documentation. You do not have to write more, but if you just from the names know what it does. So then we'll move on to, I forgot what the next slide is. Justice, you there?
This is the next slide.
It's not the next slide. I still see naming things.
Okay. I see modularity. Sergey also sees modularity.
This is very good.
I see modularity also.
So, Eike is unsynced.
I'm gone.
Is it there now?
Yeah, parts of it.
Okay, I think I'll just take over then. So next part is modularity. When we look at classes, we want to have one responsibility. So we do not want God classes. We want to see a class and we want to immediately know what is this class responsible for. This is very important just to like have an overview of all your code and how it interacts, so that you don't even have to go into the class to know what it does. When looking at methods, you basically want to have one job per method. And you may have many small private methods if you do this, but that's good, because then you can have many small private methods, and you will probably reuse these methods very often. And you really should pay attention that you only have public methods when they are necessary, so that you can minimize your public API, that's the interface that you show the people outside. Yeah, so that your class only has like 4 or 5 methods. That is enough. Then when looking at comments, this is especially something that many programming beginners get wrong. I'll just say it, comments can be harmful, because comments are often overlooked when you change other parts of the code. Like when I refactor, when I change a part of the code to get a different input, then I maybe forget to also update the comments, and then the comments are out of sync with the rest of the code, and that's pretty harmful. And each time before you comment, there's basically an easy way to prevent writing lots of comment and actually writing very clean code. Each time you want to comment, ask yourself, why do I want to write a comment here? Can I write this more understandable that I do not need a comment? And are the names correct? Yeah, I saw the comment. Are the names correct? Is it maybe because of the names that people do not immediately understand this code? And then you can clean up the code and then you can see if it still needs a comment. So good code does not need many comments. Okay, now okay. Yeah, I think after this wait a second, what do you mean?
Finish the five things and then we can give some examples. There's one more.
Okay. Oh yeah, that. Oh, you mean that? Okay. Yeah. Olivia just asked for examples, and Sergey just suggested that we make a small break for a few examples. For example, with naming things after clean code. I think we can have a look at that. Okay, but first, last sheet here, enums. We want to increase readability. So that's where enums can be used, because one thing I've seen in the last few months, that was also a code for an asset which was bought over the asset store in Unity. There were magic numbers all over the place. A magic number is, if you give that method a 1, it will do that. If you give it a 2, it will do something else. And that can make things very, very hard to understand. Now, if I use an enumeration, and then I basically have a light and dark, and it's something about the lighting system, then I know that if I pass the parameter light, then it's a light shading. If it's dark, then it's a darker shading. And also, enumerations can be used to get drop-down boxes in Unity's inspector. That's a little way in the Unity direction there, but yeah. Okay, that was it. The last thing there is to say is the Boy Scout rule of clean code. Always leave the code behind a little better than you found it. It's basically, if you look at other people's code, which is your team's code, you read it, and you find a part where you think, if I would do that and that, it would be more readable. Then you do it. You don't just think that's create a task or something. You just sit down and do it, so that the next person that sees that code has a better time reading it. Okay. Yeah, that's the part for clean code. I suppose we make a small break here. Yeah, so I'll ask Olivia directly. What part was it where you would have liked to see examples? Excuse me, what? Das dauert ewig. So, I would say it's not a good idea to go through examples for every part that we presented here. So I would just ask here where you would like to see examples or have questions. You can also activate your microphone. You don't have to answer in chat. Olivia?
So, hi, can you hear me?
Hi.
Yeah, sorry, my microphone wasn't plugged in. So the question for me is with names, because I always come up with very, very complicated names. And so, for example, a name like enemy type 1, gun type 2, bullet type 1, something like that, which is a really long name to describe something, and then you have speed at the end, or something else, or strength, or I don't know, stuff like that. So, and that's kind of, I guess, not good because the name is really long.
Yeah, a problem with a name like that is probably because the overall architecture is a little weird when you have single objects for every enemy configuration. But in general, we tend to use very verbose names when we name things, because we have an example here in the chat with sprite health, that you could also name it s_health. I personally would not do that, because everyone who looks at that variable has to then understand what s means. S could also mean stamina in this context, or something else. So that's why, I mean, we are Java programmers, and Java has that image of having some lines that are 300 characters long. And to be honest, yes, we also have some lines that are over 200 characters long, because we do have something like database adapter load only or something. These are amazingly long names, but everyone who reads them immediately knows what they do. It's a database adapter and it's a read-only adapter. So, and that's basically how we approach that subject.
Okay.
Okay. Was that it for that question, or?
Yeah, kind of.
Okay. Are there any more questions?
No, not for me. So let's see what the others say.
Okay.
I have one.
Yeah.
I would like to know why you would try to minimize the public methods to hide them from the users.
That's quite simple, because if you are a user and you look at this new class that you do not know at all, assume that maybe you, for the example of Unity, you bought it in the asset store. And then if you see like 3 methods, it's very easy. You just have to read and understand these 3 methods. If they have very clear names and very clear parameters, they're relatively simple to use. Now, if you have 10 methods, then it's more code that you have to read and understand.
Okay.
So, yeah, you basically only show the user what he has to know. The rest is all internal. If you just jump on a bicycle and want to ride to work, you do not have to understand how that chain and the pedals work.
Yeah, that's what I like to think of, is that you can change the gears, you can make it 10 speed, 3 speed, 15 speed, but as long as
Yep.
the user knows how to turn the pedals, the pedals are the public.
Okay.
Yeah. Okay. That's it, yeah.
Well, thank you. That answers my question.
Okay. Anyone else?
To Olivia's question, your object name sounded interesting. I don't know much about your game you're working on, but I would question at least if the composition of your objects, especially if you're using Unity, which I think you are, if you're Unity's component-based system might help you out a lot where you're overdoing your method names, perhaps. It's just a suggestion, but if you're not using component systems to their fullest, it might be why you're having to do such terribly specific, complex, down to this robot has 4 wheels and 2 guns, and you know what I'm saying?
Yeah, that is something that we will also be discussing quite near the end of the presentation, how you can use Unity's component system so you avoid situations like that.
Cool.
Okay, then I think we can continue. Yeah, the model view presenter, and this is a quite generic pattern. It's a very basic architecture pattern, but I think it's very effective. What it basically does is it separates the visuals from business logic. So you have code that becomes more modular. Because you have fully separated your UI from your business logic, you can actually, replace the entire UI if you wanted. So this is basically how a model view presenter looks like. We also like to call it model view something, because the critical components here are, in the bottom left, the model has the business objects and the business logic with it. Then in the bottom right, you have the view. It just has only the UI components. This could be an HTML front end or the front end of an Android app or something. And then you have presenters. Presenters, if you want to look at it in the worst way possible, they are something that combines models and views. There are model view controller, model view presenter, and different interpretations of these where the presenter has different roles. In this part, in this one particular one, the presenter performs the logic on the model objects in the model and synchronizes those into the UI. So every time something in the business logic is updated, the presenter sends that over to the UI, or the UI always goes to the presenter and asks him, hey, what's up? Something changed? And yeah, the basic rule of thumb here is always split model and view. That is something that you can apply everywhere very easily. And in games, it's basically if you want to have a rotation of your player, never ever rotate the sprite and read that value. Because if you want to later replace the sprite, let's say with a 3D model, you will have problems. That's why you always rotate. You have a rotation value on your player. And this rotation value is then synchronized with your view, which could be the sprite or a 3D model. Yeah, exactly. If you have questions, just write them into the chat. Or if you are watching on YouTube, which I see some people are, you can also write them as comments. We will hopefully see them. Okay. Then I will advance to entity systems. Now, entity systems are a little bit complicated. You will not immediately understand how to fully implement them, maybe, but understanding the basic idea of an entity system is relatively important if you are working with Unity, because they have something very similar going on under the hood. So, entity systems. They basically came into existence because multiple inheritance is nasty. If you are looking at C++ code where you have multiple inheritance, it is probably nasty code that is very hard to deal with if there's too much multiple inheritance. And if you are working in Java or C# or other similar language, you do not even have this feature. So this limits the possibilities that we have in games. A very funny example, this was taken from the source that I also have. At the end of the slides, we have a few sources and interesting literature for you. And there's a blog post explaining entity systems in depth if you are interested. And his example is Unreal Tournament's Redeemer. This is a overpowered gun. You shoot a camera that is attached to a bullet, and this bullet accepts user input. So people here that maybe don't know Unreal Tournament's Redeemer, you actually launch the weapon and then you control the bullet out of first-person view. And that is totally crazy, and it's even crazier to implement this in object orientation. Because then you have a bullet that basically inherits from a camera, it has to have user input and stuff. It's a lot of duplicate code elsewise. So entity systems, they have three parts. One part are components. They have model data. Systems execute your business logic, and entities are basically a replacement of what you earlier thought of objects in your game. This becomes very easy to understand right now. To the left here we have the entities, alien, player, target, and so on. Up here, the squares, these are our component types. We have position, movement, render, script, etc. And a component manager that knows all of these components. And here, these circles are basically instances of these components. So here you see an alien and a player have these four components, but the alien is targetable. A player can target the alien. but a player cannot target a different player. And the alien does not have physics, but the player does have physics, which tells us in this game the alien cannot jump, for example. So the interesting part is that the systems go through the components that they retrieve over the component manager, and the systems basically work as these arrows from top to bottom. You basically go through all target components, then you can get their entities, their other components, check conditions, and then you can work on it, work with it. Yeah, that's basically all for now. If you want to read up further on entity component systems, we have that blog post in the literature in the back. But yeah, the basic thing is components are basically what you use to put together your player or alien, like Lego blocks that you can just attach. And if you have a redeemer, you would just throw in user input component, throw in camera component, and you basically are done. You can do things. Okay. You can do things that you cannot do in an object-oriented environment. Okay. Last but not least, components in Unity. Unity components are a little weird for people who have never dealt with such a concept before. Also, people who have dealt with entity systems before look at Unity components and see that they contain data, like the components in entity systems, and they contain logic, like systems in entity systems. Now, the trick here is that they are already called mono-behavior. So, every script contains a single behavior. This, for example, when we take a player game object, you could have an input behavior, a health behavior, weapon behavior, and you also have physics and rendering as behaviors. These behaviors are provided by Unity. Physics, for example, you will probably be using the rigid body somewhere. That's an example. Everything that has this rigid body physics behavior is subject to physics. Then you probably have a physics system in Unity that goes through everyone with the rigid body and applies the physics and the gravity. So a health component would basically have a health value, a maximum health value maybe, and it would probably only offer two methods publicly, and that would be apply damage and apply heal, and takes a value. You maybe have a third one, probably if you want to have a UI that shows this, get health, probably. So that you can see in this example that you don't need a great API, a great public interface. Yeah, and this can all be capsuled away. Now, game object interactions is another point where I've also had a few discussions on Google Plus and on the Unity forums with some people. Because when two objects interact, you always have the option of having the player interact with the enemy, so the player has the collision code and takes damage, or does everything else, does every enemy have the collision code with the player? And basically the result of these discussions is that the player should not have this code. And as to why, the player would simply become huge, because the player would have this component called receive damage on collision. And in this component, you would check the collision, and then you would basically always be checking the type of the game object with which you just collided, with tags or layers, or if that one has some marker components, which would be components that have no content. You just check if they are there. If they are there, he's that type. It's a little weird, if you have every single enemy have this damage player on collision component, it's very easy to see damage player on collision. You do not have to go into this component to know what it does. And you probably have a public variable there, damage, so that you can configure everything in the Unity inspector. Now, if you have it like this, you can even take this damage player on collision and put it onto a trap. If you have a spike ball or spikes in game, put the script on it, that component, and you're done. You have traps. And elsewise, it could be a little complicated because you just get this huge received damage on collision component. Okay, here is the slide with the interesting literature. The slides will be uploaded very soon. I will upload them after the presentation into this chat and also into the YouTube description. We have, wait a sec, please. We have the Clean Code book from Amazon.com because we don't know where else to get books. Then we have this tmachine.org blog post about entity systems. This is by a Java developer, but it's something you can apply in any programming language. Then we have a web article, Unity Best Practices. This is a community post in the Unity tutorial section. A very good read. I just have to say, everyone go read it if you're messing with Unity. Then there's a rather technical post of Fowler. He's basically a software engineer legend, a living one, on model view presenter and similar architectures. And then, of course, we have our dev blog where we also post about some things that we have to mess around in our game development. Here we have image sources because I'm not an artist. And here's basically the summary. So for one, the project must be clearly structured. And it has to be very, very easy to navigate because you will navigate your code a lot. Everyone must understand the code. Make it readable. Use clean code. The tricky thing here is we have had it so often that after 6 months, you look at your own code and you just scratch your head. What was I thinking? Because you can evolve so much in 6 months of development, and you can learn so much in that time. And sometimes you read this old code and you maybe changed how you develop in that time. That's also something that can happen. And you just have problems understanding your own code. And now think about other people who never knew what this code was supposed to do. So readability over everything. And last is embrace your environment. What I mean by that is stick to the code conventions. You probably want to stick to the code conventions basically of the official code conventions. Like, for example, if you're developing in C# in Unity, you probably will have a better time if you do not use JavaScript or Java code conventions on your C# scripts. This is quite easy because you can then easily read other people's C# scripts online, also on the asset store. When you post your code, others will be able to read it that are from that area. And you will also have a much easier time if your company grows, which ideally everyone wants. You can easily hire C# developers for your Unity project or Java developers for your Java project because they know the code conventions. That's nothing new for them. So you actually just save money on that point. And learn the default workflow of your engine. Do not fight Unity. Do not try to treat its scripts like something different. It just doesn't really work out. And in the long run, if you are asking for help on the forums or looking to get more developers, you will want to be pretty close to the default workflow so you do not have to explain so many things. Yeah, and this is the end of our presentation. So I would say first of all, we're open for questions to the last part that we just had. Yeah. So if anyone has questions, feel free to activate your mic and speak freely.
I have a question.
Yep.
You were saying that C#, I think you said, did not was not able to implement the entity component system.
No, Unity. If you are in Unity, then it's difficult to completely implement an entity component system.
Oh, okay.
If I said that. Can't remember, but I probably said that.
There was something like that about Java and C# and having trouble with the interfaces or something.
No, they cannot implement multiple inheritance.
Oh,
Maybe
okay,
that's
okay.
that. Maybe that was that part.
Yeah, so that was it.
Okay.
Good presentation, by the way. Thanks.
Thank you. Also, thank you to Eike, who, tried to present, but Google did not like him. So
we'll have to work on that collaborative presentation thing.
Yeah, we really do. This was our first attempt on that. Are there any more questions before we go on to a discussion? Okay. Does not seem to be the case. So, what is your experience with software architecture? Where did you have problems? Where do you maybe have questions concerning your projects? Or where do you maybe have some knowledge that you would like to throw in that we did not mention or that we don't know?
I was going to say, architecture for me for video games is something that kind of evolves as the project evolves. And I know you were taking a standpoint of code readability and standards, and that's an excellent place to start. But architecture sometimes also boils down to the nuts and bolts of how you're putting everything together, right? So, like, when I'm making a new project, the most important thing to me is to move forward and get things working on the screen. And I just wondered for you, like, is anyone in the room able to go, no, I'm going to use the model view controller method, and that's just how it's going to be? I mean, I invent as I go, and then I find my way, and I start making the nuts and bolts fit together until I have an architecture. How do you guys do it?
So we started with Aileron, we started with the map editor. So we obviously started by just seeing if we could do this, just making our own voxel engine. And then we're like, okay, we want to do an MMORPG. So we have a client and we have at least one server. Right now we have a login and a game server. And then you go, okay, which data goes where? And you do this before you start implementing, because if you try to move that after the fact, then you have a load of work. And it's also not like this is just something that evolves, but you do not set the complete architecture down to class level in stone because you don't know that yet, but you set rules in stone. For example, that the server will never trust the client. It will always double check what the client told him. And this also kind of concerns architecture.
Okay, yeah, that sounds similar to what I do. I mean, those gameplay rules and networking rules to prevent cheating and there's lots of things that are in stone, but it sounds like as you start getting your system together, you start figuring out how it's going to work.
Yeah, and obviously when you see, okay, I have these things and it's all very clunky, and then you start refactoring things, like we obviously do that.
When do you know it's time to refactor?
Usually when I come along some code again, because I need to put something new in here, or I need to, for example, make something that uses this code, and then the last thing I noticed was we had several places that were building meshes for overlays, and then I decided to collapse that in one place that would put that together, and everybody else would just use this. So I started, and I took 2 hours to refactor, and then I took like 15 minutes to build the new functionality. Just that's just a gut feeling. You come along things and you see, okay, I need this, and wait, this is there and there and there, and now. But before, somebody just wanted to get it done, and you copied it, and then somebody comes along and says, no, I have to clean this up.
Yeah, I struggle with that, especially technical debt over new features when I'm not fully implemented. I struggle. I can see stuff isn't all the way how I want it to be, but I have full functional areas that need to be implemented. So I really don't know what to do a lot of times. I just do whatever I can think of at the moment.
Yeah, so anyone else? So yeah, I just said something.
Yeah, that Stack Exchange link is interesting, but it's kind of very low level, and for us it's just like we have this, and we just, instead of checking the bits and so on, and we just check if the component is there, and it's fast enough still.
Okay, yeah, how do you guys actually handle naming things in your projects?
Sounds like a question for Olivia.
Yeah, probably.
Yeah, would be interesting.
Hi. I'm not sure if there's feedback because now I'm on the speakers, but let's see. So for me, all of this is like I'm super low tech, so I'm more like the artist guy, not the coder guy. This is why I have all these kind of complicated names. And for me, is that the way why I would name it so complicated is because I want to find out where something is coming from. And you have a lot of, if you have a lot of stuff in the games, it's kind of complicated to figure out what it exactly is. Even if you have the prefabs or something, you kind of forget which one is part of which one. Like if you have different enemy types and they all have different kind of bullets they shoot, like effect stuffs, lasers or something. How do you remember which is from where and what effect it has and stuff like that? So.
Well, you usually, when this enemy shoots a bullet, you spawn a bullet, and you put the effects it should have when it, for example, collides. You put that on the bullet, and when the bullet collides, you just ask the bullet for effects, and then the remembering is there because the bullet knows what it's supposed to explode in.
Okay. But doesn't you still have to have all the information in the name of the bullet? Where it belongs to and stuff like that?
So this bullet would... Okay, if this bullet is a bullet that is only shot by one enemy, so you would just name the bullet after maybe the enemy. Maybe you don't even. And then... but yeah, that's an interesting question. This depends on how many prefabs you want to have for the bullets. If you have lots, you kind of have to differentiate them. But naming the bullet after the enemy can be misleading, because then you decide, oh, I have this new enemy, but the bullet I used over there, this one that explodes in like fireworks, this is perfect. I will just use this here, and the bullet over there is called bullet from robot enemy type 2. And then now you have pirate enemy 5, and it shoots this robot enemy type 2 bullet, and then now this is wrong. So it's just a bullet exploding into fireworks, probably.
Yeah, it sounds a little overcomplicated. It might be just as easy to just say it's a bullet, and then as it goes through and collides with things, it checks, is it the player's bullet or the monster's bullet? If it's the monster's bullet, it's checking if it's colliding with the player. If it's the player's bullet, it's checking if it's colliding with monsters. When it collides, and again, assuming they're using Unity, when it collides, it says on collision, on trigger enter, this type of object. Okay, go ahead and run the scripts that are on me, which might be an explosion or a laser blast or a fireball. Those are the other components that you've added to that bullet, dependent upon whether it was a tank firing it or a ground troop firing it and such. So you can have a fairly generic bullet, and it will look different and behave different based off those extra scripts, and you don't need to name the bullet anything fancy. It inherits from all the composition of the object that it has, and therefore its naming complexity can be very low.
Interesting. Yeah. So that's two approaches. One approach of having prefabs for everything, and then if you create an enemy, you give him the prefab of the bullet he should shoot, or
Yep.
you have code in the shoot method that instantiates a bullet and then adds components and sets them up. So if you have prefabs for these bullets, then you would obviously have to kind of name them after what components are on this, stored in this prefab. That's where I was going. So this is the firework bullet.
I used to always do the prefab methods, and I think maybe that's what Olivia is doing. But I've moved towards the instantiating in code and getting what I want. It often comes out cleaner to me, but it took a leap.
So the instantiating is that you have it's asking if, and then where's the bullet coming from which weapon, from which enemy, and then it adds the different components. But initially the bullet is just like an empty object, and it gets added all the stuff that it needs upon asking where it comes from.
Yes.
Is that how it works? Okay, cool.
You do that. So I do when you shoot the bullet, because while you are shooting the bullet, you know precisely who shoots it because he's just doing it. If you add the components then the bullet as it arrives is finished.
Yeah, I don't think either way is wrong. I just think if it becomes overburdensome in your naming conventions, if you have a prefab name that's 57 characters long, then we're talking about how do I make this easier on myself. So these are just ideas. They're not right or wrong. They're ideas like, what could I do different that might be less pain on me? That's what we're talking about.
An alternative was also presented here by Matt Thompson. He also had the idea of basically just having the bullet save the owner and the damage type, which is also something you can do. You can have components on the bullet that you configure when you shoot it. You just have an enumeration with maybe player or enemy, basically a faction, and then you just into the components of the bullet while you're instantiating the bullet.
And does this take more like power from the computer or something if you do this every time a bullet is shot? Because there could be like hundreds of bullets, and they always have to ask and then add components and stuff like that. Is that more work for the computer than just have a prefab? Or
we had performance issues in our Unity-based game, and basically the only thing that we could see that really cost a lot of performance was instantiating game objects. Like we had a minigun type weapon which just shot hundreds of bullets, and that really went into performance, but altering the components, that should actually not have any great impact.
Yeah, that's my understanding too. You could certainly test it, but that's where you have a generic bullet prefab. It's the actual game object that's going to get instantiated. And as he just said, adding a couple extra components should be lighter weight.
Yeah, and when it comes to performance, there's like a saying, I think it's from Knut. Rules for optimization. First rule, don't do it. And the second rule for experts only is don't do it yet. So when you see you have a problem, it runs too slow, then you check where it comes from and then you change something up. But before you just go with whatever works. Because optimized code is usually worse to read, might have more bugs. So Justice is writing about object pools in Unity, which you'll have to write yourself. And this is not trivial. And this can introduce bugs. So before you know you will need it because the frames drop severely, don't do it.
Yeah, I'd add to that to say, you know, I assume none of us work at Google and are multi-billion-dollar engineers. We're not the geniuses in the room. That's these engines and frameworks we're using are way smarter than we are. So write your game, and if you happen to notice a problem and can tweak it, then great. But don't spend all day bending yourself towards, oh my gosh, what if these bullets? Just run it, and if it's fine, it's fine. Don't pre-optimize. Like he said, that's a really old idiom that where you can spend a lot of cycles and never get your game done if you're way too worried about performance. Get it done, man. And if it's got performance problems afterwards, then yeah, you got a little bit extra work to do.
Yep. And optimizing is definitely something that you can kill yourself with. Speaking of object pooling and stuff already now, we were also wondering how are your guys' experience with Unity assets? Because our background is at the company we work on this Unity project at, we used a few Unity assets, and the basic rule of thumb is one Unity asset brings tons of problems. So 2 Unity assets bring 2 tons of problems. It's our experience that Unity assets are basically mostly unstable. How's your experience with Unity assets?
I don't want to be the only one responding, but
You are.
yeah, and I have a cold too, so my voice is shot. Um, I share similar experiences. Many assets are poorly written, poorly documented. They appear to have phantom reviews that are from people that were paid to do it, or just really bad people who can't be evaluating the quality of an asset to begin with, so they're useless reviews. You get a better idea if you go check out their documentation, and if it's a one-page PDF with a screenshot, you're probably not going to get something you like. If it's, they've got a whole wiki and really clear documentation guidelines and a series of videos, it might be clear that you're going to get your money's worth. When it comes to like 3D models and stuff like that, usually what you see is what you get. It's pretty safe buys. When it comes to plug-in pieces of your architecture, like say an audio system or particles or whatnot, you're rolling the dice. I have gotten a few things that I thought were great. Master Audio is one of them. I'm just like, wow, just bam, this is worth every penny I spent on it. Other ones they're a freaking mess, and I don't want to speak derogatory about anybody, so I'm not going to see which ones they are. But you have to be careful. Just buying your way to success isn't going to happen there. It brings a lot of technical debt with them. Yeah, it's easier to write your own stuff, and if you have a problem, you know your stuff because you wrote it.
Yeah, that's definitely an experience we share. We also had moments where we had problems with the Unity asset, which were partially small problems, and then we basically thought, yeah, let's just look into there and fix it ourselves, maybe. But yeah, most Unity assets we actually opened up and looked at are some Unity assets that should have maybe looked at this presentation. Because they are full of magic numbers and basically very simple problems. That's what really shocked us.
Yeah, I assume there's no quality review. They just maybe make sure the asset works when they review it in the asset store. And true enough, they usually work, but integrating it into a project is a different question altogether.
Yeah. Yeah.
So they do review them?
Well, the asset store managers, they check an asset for some kind of criteria before it is permitted to be posted. What that process is, I don't know.
I think well, there was an asset where we're like, okay, I want to find all usages of this, I think, script in the project. And Unity, at least enforce something what we're using doesn't have this. And so there was an asset in the asset store that said it could do that. And it didn't. I don't know whether they check with every Unity version or something like that.
Yeah, that's a great question too. A matrix of compatibility would go a long ways towards you're spending money, right? So some certification to its usability would be great.
What would you expect of a company that takes off its documentation offline for the older versions because the new version is launched now? So for a day. It was like when Unity 5 was about to launch or about to get announced, I wanted to know something and the documentation was offline. Hey, look here, we have new stuff. I want to know this from the forums. No, you can't have that now.
Yeah, that's a struggle too, because if you're deeply embedded in a project for a year and a half and you can't go forward with the new version and you need to finish on what you're on, that just doesn't work.
Okay. I would like to take this more away from the direction of Unity again, because more people than I thought have no Unity experience, so it would be, yeah, I think it would be nicer to have them within the discussion. So, yeah, how do you guys deal with new code? If you have new code, what is your method of getting into that code? Anyone?
Yeah, I go solo,
Well,
man. So I
yeah,
don't have
okay. Yeah. Or else I could just tell a little bit about myself how I do it. Basically, when we get new code, it's like you have these public methods, and first thing I do is look at the public methods, look at the classes, like what do we have here? Look at the names. To be honest, the names usually don't say that much, or they hide the fact that these methods have side effects. So I then check out the documentation and probably also don't see anything, so I have to go into the code. Thing that I do here is basically just go into the code with your IDE. That's probably also an interesting topic, which IDE, because basically I go in there in the code with my IDE, and then I just go to definition and just check out the code. How does it read? And yeah, basically try to find out how that thing works, understand the parts that I need, and also going into methods that say they do one thing, but if I go into the code, they probably do something else too. Been there, done that often enough. So basically, it's just navigating through the entire code one time to understand how that code, yeah, how the workflow is. How does the code flow through that? Yeah, that's very IDE assisted. um, so yeah, what is your experience there in that manner? Like, but I was also talking about code that I was not allowed to edit now. Because if you're allowed to edit the code, you basically do the same, but every time you see something that should not be the case, you fix it. For example, if you find a side effect, if you have a setter method that is just there to set something, and it touches the sorting of an array or something. Those are nasty side effects you probably don't want to have, or it just sets a different value of a different variable somewhere. So that's just something where you just immediately look at it, fix it, and in the end, the code becomes more readable and also easier for you yourself to understand. But that's something that's only possible when you actually have collective code ownership. Nobody doesn't agree?
How many people actually get to work in teams? I know the few presenters are in a team, but how many people attending get to actually work in a team environment as an indie?
That's something I haven't really thought about, because I was just used to working in a team. That's a very good question. So, how many of you do even work in teams? Okay, so it seems that we have quite a few single developers here.
Did you guys hook up via university or something, or elsewhere?
Yeah, exactly. We met in university. Yeah, then we had decided to do one of those university projects together, and it turned out that we got along quite good. So we also decided to, yeah, basically what happened was that we noticed that we got a little rusty in our development skills because university is very theoretical. You don't code all the time. In fact, you have sometimes an entire year where you don't code. So we realized that we had to code in our free time, and that's the point where we three met up and just said, "Hey, we want to learn something." So to learn something, a game is cool because you have visual results, and we wanted to learn a lot. So we said, "Let's make an online RPG." There's nothing more big and impossible we could imagine. So we started out, and things turned out to work quite well between us. So we continued working on it, and after a while, we noticed we were on our way of actually making a game that has actual visual results. Hmm. Yeah, that's also a good question. How did we end up using Unity? Wait a second, more question coming. um, yeah, so for one, we have to clarify our project is not made in Unity. Our online RPG is written purely in Java. Our Unity experience is with a commercial game that we are programming with, where we are also programming for a company that's basically right around the corner here. And in this company, we develop with Unity. So that was not our primary engine choice. It is a very interesting engine. It does has very big limitations. That's probably my the biggest downfall I see there is the limitations that you get. On the other hand, I have seen the other side and can say integrating 3D models with animations into a game engine that is not Unity or Unreal. I haven't touched Unreal. I don't want to say that it could be more complex there or less complex. Um, it's just very complicated because you really have to do a lot of things that in Unity you just drag a 3D model in there, it works. Yeah, another point to say there is we, for the biggest part, only know Unity 2D. We don't have proper experience with the 3D part. We looked at some 3D, at least I did. It looked a lot better than the 2D part. The 2D part, to be honest, was quite a disappointment up until now. Mainly due to the 2D physics being horrendous. So I'm just used to much better there. So yeah, Unity is something that we got into through our job, and our private project is in Java, and I doubt any one of us would have preferred Unity if you would have known Unity back then, because it just it really has strong limitations. And when you're doing something like such a big project as an online RPG, I still don't know how you would actually properly write a maintainable project of that size. I was also quite impressed as I saw city skylines.
when you talk about not being happy with the 2D system, was that before they came out with their, I think it was 4.6 update with the redone?
We are running on 4.6 at work. It's just the 2D physics are not what we would have liked to see. It's just that if you look at the 2D physics, what they promise and how they perform, it's just not in sync. The Unity developers were also not that happy with the Box 2D implementation that they had there. In fact, in Unity 5, they, as far as I know, they rewrote the entire 2D physics. And I think they based them on the 3D physics now. And also, while reading on forum posts, most people just say, yeah, in order to fix that, use the 3D physics and only work on the 2D plane there. So you ignore the z-axis or whatever axis that is, the depth axis in Unity.
Okay, yeah, I never done a 2D project in there yet, so I was just curious.
Yeah. Yeah. 3D project in Java, how would we tackle the animation or 3D engine? Well, for one, for 3D, we chose the JMonkey 3 engine. It is a very good 3D engine written purely in Java, which means that it's really easy to navigate the code. Don't distract me, please. Telling me not to look in the camera, which is a bit hard because, well, actually, I could pull this window over to the other monitor. Yeah, now I probably also look at you. Yeah, the thing is, we use JMonkey Engine 3 for the 3D parts, which means we can navigate the code, and the code is also relatively well written. I've definitely seen a lot worse code than JMonkey, and more often than not, we can simply navigate through the code and check out why things aren't working as we expected, which is a gigantic pro after working with Unity, because in Unity you just don't have the source. It's a horror trip for me as a developer. I want to go into the source of the physics. I want to know what happens, and I just can't. It's terrible. So that's a very important aspect. And for the 3D animation part, we use Blender, which means we can use keyframe animations in Blender. To people who do not know Blender, they are a little similar like the animator in Unity is. So you can actually just click your keyframes together and visually drag around your bones. We use a skeleton system for animation as you like, and with this we can then implement our animations and save them into the models. We then load the models and just say, hey, play that animation. So that's the way that we tackle that. But importing the models is not as trivial as it is in Unity because you have to have a very specific format, which over time somebody made a Blender importer, and it was publicly available, and this Blender importer got more and more mature, and in the meanwhile it's relatively easy if you are a skilled programmer to import these models. Back then it was a little difficult, especially with animations. It got very, very, very tricky, and I remember the first time I had to bring models into that application, it was a week until we had models with textures and animations. And that was a simple walking animation, and it did not stop. So, yeah, that's basically that for Java and animation. Speaking about Java and Unity, what is your IDE experience? I mean, experience with different IDEs, because we had a look at IntelliJ, which is basically the Java IDE. And we also know Eclipse and NetBeans and others. And at work, we now work with Visual Studio. And in comparison to that, I must say Visual Studio, yeah, it feels like a text editor, to be honest. There are so many things that are just missing. Which IDEs do you develop in, and how's your experience with that? Also with code navigation and refactorings.
I'd also say that IntelliJ IDEA is pretty awesome in the Java project. I use that at my day job. Eclipse is also great too. At NetBeans, I was not digging as much, although I've written a little NetFX kind of swing-like app in it, and it worked. It just didn't seem to have as good debug tools and such. I do like Visual Studio. Its debugger just seems rock solid, and there's so many options I can set, but maybe it's just because I've been using it for a long time. I would say anything but mono develop. But all the mature IDEs, I'm really glad that I've used different ones, is what I would say the most. Don't be afraid to try a different IDE. It will slow you down for just a little while, but you might actually find yourself going, oh my gosh, I didn't know this was possible, and your life will change. Try different IDEs if it is an option.
Yeah, that's definitely something I agree with. It's a very interesting experience also to try other IDEs. Also, if you in the long run are not happy with that IDE, you do see different features that you did not know that maybe your other IDE actually does have. Mhm. Okay, I think now the Hangout officially started at 7 o'clock. I doubt that we will be using Hangouts next time. We'll probably see if we can get something organized with Twitch or something. We'll have to look into that, but yeah, Hangouts was really buggy, to be honest. Yeah, we have one last question, basically. What are topics that would interest you for future Hangouts or live discussions or presentations? Maybe some topics that are important for your current projects.
If anyone was a hands down badass kind of a sculptor for my problem right now is I'm doing a 3D project and I've got Mudbox and I can sculpt and it looks good, but it never looks like it does in the game, like it does in Mudbox. So like I must be missing workflow, or not bringing my maps over right, and like I don't know if anyone even has those skills that can share or do a presentation, but I get my stuff in my game and it's just like, oh, it's only half as good as it was in my sculpting program. That's one that I would like.
That's sadly probably something that we cannot cover, as we are 3 software developers, and if we were to do art, it looks like, yeah, programmer's art. I
Sure.
think think everyone knows what programmer's art looks like.
Oh yes.
Okay, Meltus Swart, you write anything code related for you. Do you have something specific in mind? Because you probably don't mean hello world. One thing we could maybe talk about is I don't know if someone's interested graphics pipelines. However, it's something where yeah, our only experience is doing it once from Blender to JMonkey, and we basically have a paper doll system working there that we could talk about, but that's not something that we could hold a presentation about. It's more of a discussion topic because I am sure that we could learn a lot from other people who have done something similar. Yeah, we don't have experience with 2-year-olds while coding. Or for that matter, I don't know. I'm pretty sure that I would have problems if I did not have a distraction-free environment while coding. That's definitely something that I really would need.
I actually have one tip on that, man. I don't know if your kid's past this age, but there's something called a Moby wrap. It's this really long piece of cloth, and you wrap your kid on your chest, and they get all warm and sleepy, and they just fall asleep, and then there you go, type, type, type. If they're of such an age, it's worth the money.
That's definitely a nice tip. Gonna write that one down for future reference someday.
So for our terrain, yeah, in the model we just have a grid of squares, and you stand on one of those, like 200, 400 squares, whatever 20 times 20 gets. And for pathfinding, we just use Dijkstra's algorithm, so shortest path. Yeah, A star is overkill if the longest we need to search for is like 8 of a distance, because you can't walk fast and walk a longer distance. So I don't know if we need to do something on pathfinding, but we also don't have that much. We did some Dijkstra, and that's it. It works.
Yeah, procedural generation is, yeah, I think definitely something that we could cover someday. It's not rocket science. Another thing that we could actually talk about a little more is client-server architecture. Because that's something that we have experience in, how many? 3 projects or something? And to be honest, we basically always do the same, just on different scales. So yeah, would you be interested in something like that? How to basically make multiplayer games? Because that's one thing that we see quite often, that people just have a single player game and then all of a sudden there's an update with buggy multiplayer integrated into it.
Yeah, I think so. I know for me, doing a multiplayer project puts risk in my project. I can do a single player game pretty solidly now, but I often look at that as a check mark for a feature and say that's too much risk. There's a lot of really bad multiplayer games out there, and I don't want to be one of them. And I'm open to a lot more information about it. I don't know that I'm ready to do it, but I would attend such a presentation.
Okay. Yeah, then I'd also say we could probably call it a day. And yeah, we will probably be holding a another hangout but we got to see when we can do that and which topic and stuff. So yeah.
Cool. Thanks, guys.
Okay. I hope it was entertaining. Yeah. Then thanks for participating.
Yep. Well, good times. Thanks, guys.